This video is about how to do division shortcuts using factoring patterns. We will compare division with factoring followed by canceling, and we'll also use patterns, factoring patterns, to see if the divisor is a factor of the dividend. Let's get started. We're first going to compare division with factoring. So I will do this first problem, A, first using division, and then I'll do the same problem using factoring, okay, just to see the comparison between the two methods. All right, now in letter A, I see that I'm dividing by x minus 3. Now that's a simple, x plus or minus something, and so I can use synthetic division, okay? So in synthetic division, the coefficient of 1, now I notice that I'm missing my x term, so I need a 0 here for the x term, and then I have minus 9. Okay, the number that goes over here is this, but I changed the sign, and so I have a positive 3 here. Okay, if you want to review this method, go back and refer to my division, synthetic division video. But I'll do 3 times 1 is 3, 0 plus 3 is 3, 3 times 3 is 9, and negative 9 plus 9 is 0. Okay, this is my remainder. This is the constant term, and this is the x term. So I get x plus 3. Okay, which is a completely fine way to do this problem. Okay, you can also do the exact same problem. I'm not looking for a better or worse, but just two ways to do the exact same problem. I can also notice, hey, x squared minus 9 is the difference of squares. I have a binomial. I have something squared minus something squared. So using my factoring patterns, I have x, and I have 3 and 3, and I have minus and plus. Okay, notice the bottom is x minus 3, and that these cancel, and so I'm left with x plus 3. Now I know you might say, well, the factoring method just looks faster and easier, and it's true if it works out. Okay, it's just one more thing to look for. Again, you can always go back and use division, but you can look for, hey, I see a factoring pattern. Would that help me in the future as a thing to check for? In this video, I next want to do number 3, do the exact same thing because something else happens in number 3. All right, we are again going to use division and then use factoring patterns. Okay, again, I'm dividing by x minus 3. That's a simple thing. It's x plus or minus some number. So I will again use synthetic division. Okay, I'll write the coefficients over here. I'm missing x cubed and x squared and x. So my coefficients are 1 and 0x cubed and 0x squared and 0x and minus 81. And then the number I put over here is the change of signs of this minus 3. I'll put a positive 3 here. Again, if you want to review synthetic division, go see that video. I'll bring the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 0 times 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. 0 plus 27 is 27. 3 times 27 is 81. Negative 81 plus 81 is 0. So my remainder is 0. Constant term, x squared term, x cubed term, and I get x cubed plus 3x squared plus 9x plus 27. Okay, now the exact same problem using factoring patterns. I will notice that x to the 4th minus 81 over x minus 3, that on the top, you may not notice it at first. You'll say, oh, hey, do we have a difference of 4th powers? And we don't really, but we do have the difference of squares. Okay, x to the 4th is something squared. It's x squared squared. Okay, so what this factors into is x squared, and x squared has become x to the fourth. Okay, and 81 is also something squared. It's 9 squared. Okay, so I have minus and plus over x minus 3 as the first step. Okay, now we do not have any sum of squares. There isn't a sum of squares pattern, but there is, there is a difference of squares pattern. So I can apply that same pattern again to my x squared minus 9. Okay, again I have x times x is x squared, and 9 is again a perfect square. It's 3 squared, so I get 3 and 3 minus and plus. I will bring down my x squared plus 9, bring that down here, don't lose it, divided by x minus 3. Okay, and I will notice that I can cancel off this and this, and what I'm left with is x plus 3 times x squared plus 9. Okay, now if you're wondering, hey, wait, you didn't get the exact same thing as on the left-hand side. Well, I do, but it's in a factored form. And to see that, we will expand this into standard form. So you do get the same thing either way, whether you say that one's easier or harder or longer or shorter. The point of this discussion is that you can do it either way. There's just multiple tools you have, either synthetic division or using factoring patterns. Next, we're going to look for more factoring patterns to determine if the divisor is a factor of the dividend. Okay, if it is, then find the quotient without doing any math computations, meaning without doing any division. Okay, so in letter A, I notice x squared minus 144. That looks like the difference of squares. Okay, so I have, let's see, a difference of squares. I have what squared is x squared? That's x. And what squared is 144? Well, it's 12 and 12 minus and plus divided by x minus 12. This will cancel with this, and because it cancels, it is a divisor. And we can also see from this work that the quotient will be x plus 12. Let's also look at letter C. C is x cubed plus 125. We may notice, hey, that looks like it's the sum of cubes. Okay, x cubed is something cubed, 125 is 5 cubed. So I'm going to use my sum of cubes pattern. Let's see, I use the same sign, and then x squared, and then x times 5, change the sign. I get minus 5x, and then 5 squared is plus 25. If you want to review that pattern, go back and watch the video about the sum or difference of cubes pattern. And that's divided by x minus 5. Okay. Now I will notice that these, let me actually use a highlighter, that these are not the same because the signs are different. Because the signs are different, x minus 5 is not a divisor of x cubed plus 125. All right, and then I don't need to find the quotient because it doesn't really divide. In example 3, we're looking for what is the quotient of x squared minus a squared over x minus a, and we're using pattern recognition, meaning factoring patterns, to do this division, and then we'll check with long division. Okay, I'll notice that x squared minus a squared is the difference of squares. Okay, so I'll use that factoring pattern. And let's see here. X squared is x squared, so I get x and x. And a squared is a squared, so I get a and a minus plus. Divided by x minus a, and I notice that this cancels with this, so the quotient is x plus a. And I'm going to check this using long division. Yep, and you get the exact same thing, x plus a, using long division as well. Okay, I'm not trying to find the better situation. Be aware that you have both tools to use to answer any question. All right, this video is about division shortcuts using factoring patterns, comparing division with factoring. Thank you for watching.